video on temperature. So far, we've learned that temperature is the unit. So let's just write the summary down again. So we learned that temperature is a measure of how quickly particles are moving. We learned that 0 Kelvin is absolute zero, and it's also negative 273 degrees C. Maybe I'll use asterisks instead of dashes because they look like they could be negative. It's absolute zero. And we learned that temperature causes a different, we'll just say different distribution of speeds in a substance, a solid, liquid, or gas. That's what we did in the previous video. Now this one is looking at that actually temperature boiling or evaporating or freezing or cooling can have different points, different temperatures. So in other words, if we have a look on the bottom, this is temperature, right? So I'm just going to make sure we understand what we're writing here. So the x-axis is temperature, and the y-axis, I don't think I'm able to rotate this, which is a bit frustrating, but the y-axis is pressure. If we look at this carefully, we can see that if I were to get this, in fact, they've done it for us at 0 degrees C. This is for water. This is what we call a three-phase equilibrium. Basically, it's showing you how the different phases or states are. They don't always have. We say that that water freezes at 0 degrees C, but that's not actually necessarily true. In fact, if you were to go at 0 degrees C, then something very strange happens, because you can see here that at 0 degrees C at 0. Well, at this, let's say at this, we imagine this red line. This is the one particular pressure, and we can see that as I get hotter. So let's if we draw a vertical line now. Let's say what would it be? What would it be at this temperature here? Well, I join up these two dots, and I can see it would be a solid. And then, but if I go all the way to this pressure, 0 degrees C, it's actually a gas, bizarrely enough, which is strange. In fact, I can go quite a bit. I can go quite high. In fact, it looks like at all the way up to here. Well, obviously, at hotter temperatures are going to be a gas anyway, but at quite cold temperatures, water's a gas. At low pressures, then water becomes a gas, and until you go hot enough, and then it jumps straight into a solid. So at this low pressure, you can't have a liquid water. And in fact, the boiling point, the point at which a liquid turns into a gas, the temperature changes. We know at 1 atmosphere. This is like what we can say. Let's say normal pressure, or normal air pressure, right? At normal air pressure, we can see that that solid becomes a liquid at 0 degrees C, and the liquid becomes a gas at 100 degrees C. But that it does change. In fact, what you can do is you can, with this simulation, you can move this thing around, and you can. So in fact, oh, this is quite cool. So I didn't know it did that actually. So I can go from here to here, and it's showing me that going that direction, just uh, going that direction, we're keeping the same pressure, but reducing the temperature. It goes from water to ice. I can start here and keep the same temperature and just reduce the pressure, and I'm going from water to steam. I could start here, and I could reduce the temperature, and I could increase the pressure, and I can go from steam to liquid, from gas to liquid. So it really does actually change. Now, what's a supercritical fluid? I'm not quite sure what a supercritical fluid is, but it looks to me like it's something that's not quite somewhere between a gas and a liquid. Maybe we can have we'll quickly see if we can find out what that is. So when it's a supercritical fluid, it could either be a liquid or a gas. That's basically what that means. In a nutshell, I'm sure it's maybe slightly more complicated than that. So basically, the point that this diagram is showing you is that the boiling point and the melting point doesn't just depend on temperature like we've learnt before, but also depends on pressure as well. So I'm going to cut that video short there, because there's not a whole lot more you really need to know at GCSE, and to be honest, even at A level they don't go into it that much detail. So I'll stop that video there.